Hello and welcome. I'm here to tell you about iOS app development. iOS is an operating system created and developed by Apple for its mobile devices such as the iPhone, the iPad, and the iPod Touch. It is a scaled version of the macOS, uh, which is used on Apple computers such as the iMac and the MacBook Pro. Now, it was first released in 2007 when it was launched with the first iPhone, and every year a major version of iOS is released. So, currently, we are in the ninth iteration of iOS that was released this year. Now, Apple has sold over 1 billion iOS devices, and their App Store has more than 1.4 million apps and have been collectively downloaded over 100 billion times. Therefore, iOS is a fantastic platform if you are looking to launch your career in mobile app development. To start with, you'll need a macOS computer system. Uh, you will need a basic knowledge of object-oriented programming concepts uh, because the language we'll be using is Objective-C, which is derived from the C programming language. Uh, but the most important tool you'll use is Xcode, uh, which is the IDE and contains the iOS SDK. It can be downloaded for free from the Mac App Store, and when you open it, it greets you with this welcome screen. To create a new app, we need to select this option in the welcome menu, uh, which will help us create a new project from the different templates provided. We'll select here the most simplest of them is a single view application. Click next. Here we'll have to provide a name for our app. I'm putting as a test app. You'll have to provide your organization name and the organization identifier in reverse domain name notation, which will in turn create the bundle identifier. Now, the bundle identifier has to be unique for every app you create, so you need to name your product and organization accordingly. And now we select the language as Objective-C, and in this case we are only developing for the iPhone. So we click next, and it'll ask us for the location. I select desktop and click create. This will create a number of different files from the template we selected. So what we have created here is a completely bare bones application. Although it's a valid iOS application, we can install it on a device, run it on the simulator, and see how it works. This is the run button here, and we can see it's a completely blank application. So let's try and add some features to it to see how it works. First, we need to know what files we have to work with. First, we have the app delegate file. There's the H file and an M file. The H file is the header file, and the M file is actually where we write the code to modify the behavior of the app. Uh, the app delegate helps us to manage the whole life cycle of the app from launch to when it enters the background, the foreground, and till the application terminates completely. Then we have the view controller file. Again, we have a header file and the main file. Um, the view controller file helps us manage the behavior on the view, which we have in our app. Then we have the storyboard file, which contains all the UI resources we have. You can see we have the view controller here, which contains a single view, which is completely empty, as we saw when we ran it on the simulator. We can add elements to it from the object library here. Now we have a lot of objects to choose from. We can add more view controllers, table view, collection view, etc. And there are simple elements like a label, a button, a text wheel, a slider. So let's add a button and see what happens. So we add a button here, and it's added to our view here now. And then we run the app again here. and see that the button appears here. Now we can tap on it and see that it's interacting, but since we have not added any actions to it, it doesn't really interact. So let's try and do that now. Now there are a number of ways with which we can add an action to a button, but the simplest one we use is by using the assistant editor. By clicking here, this opens up a side-by-side view of our view as well as our view controller. So what we do here is right click and drag from our button to the view controller and drop it. So it'll open up a dialog where we can give a name to the action like tap button action, and the event will be touch up inside, which means that it will register all touch events within the bounds of the button. And then we click connect, and there you have it, the action has been created. Now whatever we add inside the action will be the behavior which we want when we tap on the button. So let's say we want to open an alert to show the user. So we use a UI alert view, name it as ALT, and we allocate it, and then we initiate it with a title saying hello, and with the message saying hello iOS. Now we do not need to specify a delegate here, so nil. We can have a button named OK, and no other buttons needed for now, so other buttons will be nil. So this creates an alert view. Now we need to show the alert view, so we use the name we gave to it, alt, and invoke its show method. So alt.show. Now let's see whether this works or not. We resume the view and run the app. It's compiling, succeeded. Now, moment of truth. Let's see what happens when we tap the button. See, a dialog appears with our title and our message and the OK button. So we click OK, it disappears. We click again, it appears again. So that was a decent first step to begin with. Moving forward, let us see how we can work with different kinds of texts in your app. So we go to the object library here, and let's select a label. A label can hold different kinds of static text. We can change its dimensions like this, or by using the size inspector here. Here we can put in the coordinates and dimensions for the label. This here is called the attributes inspector. Here we can put different attributes for the label, like what the text would be. Say this is a label. We can change the font color. Let's say we put it as blue, or maybe green. We can change the fonts and their sizes. Let's say Arial, and we increase the size to 21. You can see the text is getting cut off. That is because the lines attribute here is set as 1. Now we can set it as any number of lines we want, but if we are not sure and we are supposed to have multiple lines, we can just set it to 0. So this will make a label have multiple lines. Now we can set the alignment as centered, right, anything. Um, so this is for basically setting a static text. We can also change this text in this label via our code during runtime. For that, we need to have an identifier in our view controller here. So to do that, we again use the assistant editor here. We right click on our label and drop it here in the interface section, and this gives us a dialog. Let us put it as my label and connect. So this creates a property here on my view controller file. Now if you want to change the text on my label, say on the tap of this button, so let's say we not show the alert, and instead of that we use this file's my label, and its text equal to, let's say, is text. Okay, that's simple enough. Now let's see whether it works. We run it, it compiles and attaches to the simulator. Here we can see that our static text has appeared on the label. Now let us tap the button and we can see it change. So another kind of text we can have is an input text, for which we use a text field here. A text field can display any kind of editable text. It can work with editable text. So whenever we click on this field here, the keyboard shows up and we can type in text in it. We can have text already placed in it. So let's see, the attributes we have are pretty much similar to what we have on the label. We can change the color, the font, and the alignment. The new thing here is we can set a placeholder here, and we have different border styles here. So this, or even a plain one. Let's use the default one, and let's say we have a placeholder, says type anything. So, but the limitation with the text field is that it can display only one line of text. There's no provision for it to have multiple lines. If we need to use if we want to use a field where we need to input some text or put some editable text in multiple lines, we use a text view, which comes further down the line. See, this is a text view here, but for now we work with text fields, and again, to use the text field in our code, we need to have a property for it. So again, we'll use the assistant editor here, right click here and put an interface here to insert the outlet. That gives us the dialog. Let's say we name it my text field and connect. So this creates an outlet for my text field. Now what do we want to happen here? Let's say we type something here on our text field and click the button, so the label shows the text which is inside the text field. So we can, instead of the static text here, We can put it as my self dot my text field dot text. Okay, so let's see whether this works. Again, we run it to compile it on the simulator and see our field has appeared. Now when we touch it, it shows us the keyboard. Let's say I type my name here and click the button, change the text on the label. Say I type my full name, again click the button, it shows my full name on the label. So next, let's take a look at how to use images in our apps. For that we need to use this folder here. This is our asset library, and we can import images here from anywhere. For example, I can drag and drop this image here and give it a name, say my image, and we can use this in our app now. Let's see what is the size for this image. This is 115 by 115 pixels. So this is basically a square image that we have. Now to display this in our app, we need to use the object library, and there we get an image view. Now the image view here, we can change the dimensions here to make it square, say 115 115, and using the attribute expector we can add the image into it. So here we have our image displayed in our app. Now usually we are not sure when we are getting different images from different sources what particular image size we are going to use, but our view has to be fixed inside the app. So we can use something called view mode here to make sure that our image does not get distorted. For example, if we keep using the default mode, that is scale to fill, and if our view is say like this, so you can see the image completely fills the view, but gets distorted in the process. So say if we change the view mode to aspect fit, we can see the image retains its aspect ratio and does not get distorted, but the parts of the view are left blank. If we use aspect fill, we can see the whole view is filled, and also the image does not get distorted, but parts of the image are cut out as they are left outside the view. Now we can also see that as we change the dimensions, the aspect ratio is adjusted with the image size, so that the aspect ratio is maintained. Now we can also add this image onto this image view via code. So let's see how that happens. For that we'll remove the image from here, from the attribute inspector, open up the assistant editor, and add an outlet for this image view. Let's call it my image view. So now we use our tap button action here to add the image to our image view. So we use the image view property, my image view, and it's set its image attribute to the image from our library. For this we use the UI image class and its image named method. the name we set as my image. Now let's see whether this works. We run the app and see it on the simulator. So here we, but let's see what happens when we tap the button. Here the image appears not distorted, as the view mode we had used as aspect fill. And now we can do other things with an image view. Instead of just assigning an image, we can have a background color when there is no image view. To set the color, we use the UI color class, and the UI color class has a lot of preset images like red, it has blue, black, it has green, gray. So let's assign a green color to our image view. So there'll be no image, just a green color view. So let's see how this works. So now when we tap the button, you can see our view has taken a green color. Now we can assign a custom color to it with the color width method of the UI color class. The RG and B values we have to assign in a ratio of 255 as it is. So let's see, we assign red, blue and green all as 110 by 255, and the alpha value will be 1, so because we do not need any transparency here. So now we run it again, and we can see, since all the RGB value is the same, it should be a grayish color. So here you can see a gray color view appears. Now what we can do to make it fun is assign random colors to red, blue and green whenever we tap the button. So let's take a floating point value for red and set it as a random number modulus between 0 to 255. Now we can have this same two random values for green and blue as well. So instead of assigning a number here, we assign red, we assign the blue value, and we assign the green value here. Sorry. So red, green and blue values randomly assigned whenever we tap the button. Let's see how that works. You see it, this is a bluish color. We tap the button again. Now it's a bit brownish, beige. Okay, see, you can see the colors come instantly as we tap the button. Now to make it even more interesting, what we can do is make it an animation. So the image view is a subclass of the UI view, and we can animate views using the UI view class's animate with duration method. So the UI view class has an animate method with duration. So let us set the duration as 1 second, and here we put the code of what animation we need to do. So we put this code here of the background color change inside this block. So this should what this should do is make the color not shift directly from one state to the other, but in a gradual way. See, there's more black, now it turns to green, now it turns to purple, to green again, to blue, another shade of blue, well, a bit lilac, purple, green again. So I guess this is enough for today, and hope you enjoyed the session, and have fun. Have a good day.